Okay, discuss this question paper. It's a common test by KZN, March 2025. It's mathematics. Most question papers that are written in March, it's not a matter of paper 1 or paper 2. It's just a combination of wonke umsebenzi onowenzile for that particular term. So lana ke sizoba no common test KZN paper. Now we're going to have a walkthrough for the entire question paper from question 1 to question 5. Let me demonstrate it's a combination of umsebenzi owenze for term 1. So this is question 1, my number patterns. It's the arithmetic sequence. Then we have question 2. It's a combination of each geometric and the quadratic. Then we have question 3. It's a function. It's a hyperbola and a parabola. Then we have the last part of question 3, the parabolic function. And see what question 4 is another function. It's inverse functions. Then the last question, the second part of question 4, it's another function as well. And then this is question 5, trigonometry. We know that trigonometry is ithola paper 2, but for this particular paper it was included in the common test because trigonometry was done in term 1. Alright, thanks for tuning in. If you do enjoy the content, please leave a like, share, comment if you have any questions. Going back to question 1, number patterns. Let's talk about this one again. First, do I have the right pen? I think so. Okay, so 1.1.1. But hey, you are given the sum to n terms of an arithmetic sequence. So this is a sum formula, right? So we are given Sn equal to 3n squared minus 5n. Let me just erase it squared la minus 5n. Okay, so this is the formula that is given. I'm rewriting it because I suspect on the recording. Now they want us to calculate the sum of the first 21 terms of the sequence. Okay, this is just a matter of substitution. Sizala. We want the sum of the first 21 terms. So n becomes 21. So 3, 21 squared minus 5, 21. Then we calculate 3, 21 squared minus 5, then go about 21 equal to ngithola 1218. 1218. So just a piece of advice. Now abubukela ama recordings online. Don't just watch for the sake of watching. Have a calculator in hand or even a pen and pad at the same time, so that now bugela just pause during the recording and then try to do the problems on your own, and then can't you or can you get the same answers as in Fundisa kanje, so or whichever instructor you'll be watching online. All right, just a side note, I think that becomes much more effective and productive rather than just watching. Okay, now determine the 22nd term of this sequence. The 22nd term of this sequence. All right, you know what I think for this one, so if another 20, okay, I see. Now we are still given this is the only thing that is given or provided. Now you are given a sum formula. Now bakupha i-sum formula kanje, so bafuna calculate a particular term. They want you to calculate the value of a particular term in the sequence. However, they're giving you a sum formula. All right. On such a case, if say maybe you want the second term. Ufuna T2. This is how you get to T2. Uthola the sum of the first two terms minus the sum of the first term. If ufuna the third term, you take the sum of the first three terms minus by the sum of the first two terms. And then in our case, ngoba sifuna ulo kanje, sifuna term 22, T22. The T22 we're gonna calculate by saying sum of the first 22 terms minus the sum of 21 terms. Alright, the first two I'm just illustrating or just demonstrating how to calculate our terms using a sum formula, right? Now this is how we're gonna calculate T22, by taking the sum of the first 22 minusing it with the sum of the first 21 terms. All right, but lucky for us, on the previous questions we calculated S21, so now our task is to calculate S22. S22 is going to be equal to 3. Still using that formula, we're going to substitute to 22 ct squared minus 5 to 2 equal to, then ct3 to 2 squared minus 5 to 2 close, then go about 1 3 4 2 3 4 2. Then we bring this over here, so T22 is equal to sum 22, it's 1 3 4 2. Then we take the 1 we calculated above, c minus I 1 8, then ct 1 3 4 2 1 3 4 2 minus 1 2 1 8, then c no 1 2 4. So this is T22. T22 is 124. Now while see like the question, maybe on your own try calculating, say maybe T78. Try calculating T78. Okay, now CISO. Okay, I don't think I have enough space, so let me just erase that. Then is a 1.1.3. How many terms of this sequence must be added to obtain a sum of 8162? Now we are given Sn equal to 3n squared minus 5n. We're still going to use this formula. All right, we're still going to use this formula. Now but there's a particular sum which is 8162. Now the question is, how many terms must be added to get this 8162? So funokwazi ukuthi what is the value of n if the sum is 8162. So in the place of Sn, we're going to substitute to 8162 equal to 3n squared minus 5n. Then we transpose, go about 3n squared minus 5n minus 8162. All right, we have a quadratic equation. We take out our ABCs. This is A, this is B, then this is C. Then we substitute into the quadratic formula. Then we calculate for n. So n is going to be equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. N is equal to minus b, that's minus 5, plus minus the square root of b, which is minus 5 squared minus 4, then a, that's 3, c is negative 18162 close bracket divided by 2, then a with the regular, then n is equal to ct minus ct negative 5 ct plus, let me start with the plus, minus 5 squared minus 4 close open bracket 3 close bracket open bracket minus 8 1 6 2 close bracket divided by 2 3 vala bracket. The first answer is 53, but no, okay, it's 53. Normally the second answer, it's not gonna be an applicable one. It's either you put a negative or a decimal, as I expected. The other n is gonna be equal to minus 154 divided by 3. So since it's a negative, this one is not the correct one. Your n value shouldn't be a negative, a fraction. It shouldn't be a negative, a fraction, or come out as a decimal. It should always be a positive integer. Like in this case, it's positive 53. So 53 terms, when adding the first 53 terms of the sequence, you're gonna get to 8162. Going to 1.2. 1.2, what do you consider the sequence? 7 7 7 12 7 17 7 2. Now almost ithatha like this. If you're gonna take it at face value like this, we thatha usebenze ngayo njengoba iso, you're gonna run into some problems. This is actually a combination of sequences. So it's a combination. Let me just rewrite it on the side. 7 7 7, then go about 12, go about 7, go about 17, go about 7, go about 22. Okay, go about 22. Lana, there's a difference of 0, a difference of 0, and then a difference of what? 12 minus 7, that's 5. That's 5. Yaboguti, it doesn't fall under any common sequence, geometric or arithmetic, or even quadratic. It doesn't fall in any of the common sequences as well, but rather it's a combination of sequence. If you take a look at, if we study Shagatle, man, you'll see that for the first term number 1, then term number 2, term number 3, term number 4, term number 5, T1, T3, T5, T5. We have ukuthi kuba nabu 7. So for every odd numbered term position kule sequence, for every odd numbered term position in the sequence, we always find a 7. 1, 3, that's an odd number, it's total 7. 5 is an odd number, it's total 7. 6 is not an odd number. Term number 6 is not an odd number. Term number 7, odd numbered, so total 7. Then 8, it's even. Then 9, I'm expecting to find a 7 again. So for every odd numbered term position, we find a 7. We find a 7. We find a 7. Alright? So singawa isolate lama patterns now. There's a pattern yabu 7, then siba ne pattern eqala ku 7 iye ku 12 iye ku 17 iye kubani ku 22, then you continue all the way up to infinity. Alright, so I'm saying let us isolate lama patterns now. So we have this first pattern yaga 7 7 7 by 4 7. Then siba nenye lana I pattern 87 12 17 22, then it continues to infinity. Alright, so it's number pattern I2 yabo 7 and this one. Taking the difference between these numbers on the second pattern, sithola u5 la, and then 17, another 5, another 5. So we are dealing with an arithmetic sequence in this case. All right, in this case. Now, level 7 spatola, when we have an odd numbered term position, and then the arithmetic sequence itola if we have an even numbered term position. As you can see, 2, 4, 17, then T8 is total 22. All right. Now, for the first question, but it determined the value of the 78th term of this sequence. All right. So the 1.2.1. Okay, maybe let's read the question again. Determine the value of the 78th term of the sequence. Now, as well, let's go back here. Sitheni sinama sequence ayi-2. We have the odd numbered sequence. Meaning that it's the pattern ephuma from ama even numbered term positions. Then siba another second one, which is coming from the even numbered term position in the original sequence, which is this one. So separate it to this and that as well. All right. Now, if we talk bigger, that value that you calculate, it's an even numbered term. So it means that that term, the value esifunayo, the value of the term that we are looking for, it is landing on an even numbered term position, which is 78. Okay, 78. Okay, yeah, ne? Let's go back to the original. So, term 1, this is term 2, term 3, term 4, term 5, term 6, term 7, term 8. It's a bit of a challenge explaining this thing, but you'll get it. Now, njengoba ngishizo ukuthi the 78 term, it's gonna land, or it's gonna end, or it's gonna be part of the even numbered number pattern, the arithmetic sequence. Okay, so in order to get the value of the 78 term, it means that we're gonna use this number pattern. It's not gonna be a value of 7. If mhlambe it was an odd number, mhlambe say I don't know, maybe T21, we know ukuthi yolanda kubani ku7, because we have to term 21 is odd numbered, so it's gonna be a 7. But if maybe it was T26, T26 is even numbered, it means that yolanda kupi arithmetic sequence. We're gonna have to use the arithmetic sequence to determine the value of T26. T78 or 78 term, it's a even number, so it's also in the arithmetic sequence. But now kumele understand something, because we need the n value, right? And you can substitute the 78 and calculate the term, right? Ngoba the original number pattern sihlukanisile into 2, into the 1 yabu 7 and the arithmetic sequence. And the T, or the 78 term abayifuna in this pattern, not go arithmetic, not lana, bayifuna in the original pattern. And the original pattern doesn't follow an actual pattern. Thina sihlukanisile into the yabu 7 and the arithmetic sequence. Now pay attention again. Uyambona T1, I mean U7, T2 in fact. T2 in the original, because we're gonna be using the second pattern, the arithmetic sequence. T1 of the arithmetic sequence is actually T2 in the original one. then t2 in the arithmetic sequence is term number 4 in the original, then t3 is actually term number 6 in the original, then term 4 of the arithmetic sequence is actually term number 8 in the original. I don't know if you do spot the pattern by now. The pattern ukuthi, if siyofuna t78, we need to take t78, so t78 divided by 2 sithole ubani u39. Therefore it means that t39 is gonna be equivalent to t78. Bheka, ngifuna ucalculate t78, ne? T78, which is found in the original pattern. The t78, the value of t78 is gonna be equivalent or the same as t39 in the arithmetic sequence, right? Because the arithmetic sequence sithethe from this original, it's the shorter version of lapha phezulu. You know what, I think I'm explaining a lot. Let me just do this. The 78 and 39 ngizoyi explain again once we start doing the calculation. Now let's calculate a value of 78. So Tn is equal to, so sebenzisa the arithmetic sequence formula. D is equal to, what is A? A is the first term, so the first term lana ilo 7, we substitute, plus what is N? Now if ngisebenzisa 78, the answer ngizoyithola izoba wrong. Why? Because the 78 is the term position in the original sequence, right? And the original sequence doesn't follow an actual pattern. Now I'm substitute to 78. I'm substituting with 39. Why 39? It's because of I'm using the arithmetic sequence to calculate the value of t78. Now the 78, let's say you allow 78. The 78 izofana no t39 lapha kuloka arithmetic sequence. The difference is what? It's 5, right? And now we are born man. T8 ufana no t4 la. Ufana nokuthi uthethe u8 wamdivide ngobani? U2. T6 uyafana no T3. Ufana nokuthi uthethe u6 wamdivide ngobani? Ngo2 wathola u3. T4 uyafana no T2. Hence I'm taking u78 and dividing it by 2. Hayi, komele uyibambe manje. Komele uyibambe manje. Minus 1 times 5, then kuba 197. So this is term 39. Therefore term 78 is equal to 197, right? 197. Ile nto bengi explain la ukuthi t39 in the arithmetic sequence uyafana no t78 in the original pattern. I hope it makes sense. I hope it does make sense. If you have any questions, singakhuluma ku comment section. Okay, now let me just erase this part. Okay, all right. See, I get it loaded again. Okay, let's erase. Okay, take down this. Okay, so manje we do the last question, lagu question 1.2.2. The 1.2.2, let me use this. Now they want us to calculate the sum of the first 103 terms of the sequence. Now uzofuna ukuthi ngibhale le pattern again like this. I'm gonna use it to explain this. 7, 17, 7, then go about 22, then it continues. Okay, so this is the pattern yabu 7 7 7 7, and then sibanale pattern, this one, this one, this one, this one, which is the one for a arithmetic sequence. Now calculator the sum of the first 103 terms. Now this is term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8. Okay, term 8. Now yabona jengala, like in this pattern leyiphelela ku T8, you can see that ukuthi if we have even, if the pattern ends on an even numbered term position, it means that there's gonna be equal number of abu 7 and an equal number of the arithmetic sequence. Jengala phelela ku T8, so bana ku 7 abayi 1 2 3 4, then the remaining 4 is for the arithmetic sequence. Okay, so it's like saying that ngoba le pattern iphelela on 8 terms, we divide this by 2, sithola 4. So it means that there's gonna be 4 terms for leabu 7, and then there's gonna be 4 terms for the 1 year arithmetic sequence or arithmetic pattern. Okay, arithmetic sequence or an arithmetic pattern. So there's gonna be 4 abu 7, 4 yabu loganje. But what if the pattern iphelela on an odd number, term position? Let's erase la. Let's try and erase. So ngsusalo 22. Okay, I understand ukuthi this pattern iphelela ku 103. I'm just trying to lay some foundation so that nang discuss a solution, you know what I'm talking about. Now what if iphelela ku T7, right? So to approach this, I would say ngiyathatha u6 divided by 2. Yes, iphelela ku 7, but I'm just taking or putting 1 on the side. I just want to make it an even number. So you have 6 divided by 2, ngithola ubani u3. So it means that you have 3 yabu 7 and 3 yabu loganje, yabu arithmetic sequence, and the arithmetic sequence. Yabon? But ngoba it ends on an odd number, that one in place on the side, it's actually a 7. So we have plus 1. So we have abu 7 abayingaki nabaphelele by 4. By 4 abu 7. Njengoba ubona la bayingaki 1 2 3 4. Okay? 3 4. And then the arithmetic sequence you have 1 2 3 values. Okay? 3 values. Now I think erase la. Let me erase lana. Now ngoba the pattern in this particular question, but it's for the first 103 terms. 103 terms. Again, ngizoyisplita ngithi 102 so that izokwazi ukudivideka le number. Plus 1. This plus 1 represent ubani u7, right? Ngoba ngiqale ngo7, if ngiyophelela nge-odd number lapha ekugcineni, it means that ngiyoba no7 or extra. I hope it does make sense. You have any questions, let's talk in the comment section. Okay, so iphelela ku 103. I'm gonna split the 103 into 102 plus 1. The plus 1 represents an extra 7. Okay, therefore need to 102 divide by 2. Ntola 51. Ntola 51 sevens and 51 terms in the arithmetic sequence, in the arithmetic sequence. But in actually labo 7 by 52 because of that extra one, right? Then you can check now 52 plus 51, it takes us back to 103. It takes us back to 103. So mina 7 abayingaki abay 52, right? Okay, just another demonstration or another example. I feel like I'm confusing myself, and whoever's watching or will be watching this recording, I maybe might feel a bit confused. Or instead, let me just use maybe this nitiso. Nope. Erase this part, going back. Okay, perfect. So now example ngifuna something ozokhona ukuyibona rather than something ingekho la. Ngifuna something ozoyibona njengala. Abu 7 bayingaki? Yabona iphelela on T5. Abu 7 bayingaki? By 1 2 3, and then arithmetic sequence here to how many terms do we have? 1 2, right? So using this logic, I would say yothatha the 5 ngimsplit ngithi 4 plus 1, there's an extra 7, so it means that yoba nabu 7 abai 2, abu 7 abai 2 plus that extra 7 plus 1, so kahle kahle nabaphelele bayingaki? By 3. That plus 1 represents an extra 7, plus 2, the other 2 is for the remaining terms, that represents the arithmetic sequence. Now to get the sum is what? The sum of odd number terms, odd numbered terms is equal to 7. Abayingaki? Abay 52. So it is 7 times 52 is equal to 7 times 52 inginikeza 364. Then sum of even number terms is equal to a plus n minus 1. This represents the arithmetic sequence, is equal to what is a? A represents the first term, which is what? Which is that 7 plus n, it's gonna be what? It's gonna be 51. 52, it's for the odd. 51 is for the arithmetic sequence. So the arithmetic sequence in total for the 1.2.2 103 terms, una 51 terms in the arithmetic sequence. So that is why n yomthatha is 51. Difference, it's 5, equal to, then solve 7 plus 1 minus 1 times 5, then go about 257. All right, therefore it's the sum of 103 terms. 103, it's gonna be the 364 plus 257 plus 257 plus 257 until 621. Okay. Look, I made a blunder. I'm actually calculating a term instead of the sum. So this thing, it's wrong. My apologies. So sum, not term, sum. So it's n over 2 and then 2a plus n minus 1 times d. Yeah, I made a big mistake. It's 51 over 2, then go about 2, then a, it's 7 plus 1 minus 1, then difference, it's gonna be 5, equal to 51 over 2 Then go about 2 times 7 plus 5 1 minus 1 times 5. Okay, syntax, I think it's this bracket. Yeah, then in total 6 7 3 2. Therefore the sum of 103 terms, it's gonna be 364 plus 6732 equal to 364 plus 6732 equal to 7096. This is the final answer, and the total sum of 103 terms. Okay, so just be very careful when it comes to number patterns that are a combination of number patterns. In other cases, you might find ukuthi by separating the number patterns, you actually get a geometric and an arithmetic sequence at the same time, or even a quadratic and an arithmetic. Anything is possible. All right, now let's go to the next question. All right, now the question 2, it's another question on our number patterns, geometric and quadratic. So we have this 2.1.1. We are given a sigma notation for this question. Okay, yeah, perfect. Then we are given a sigma notation. We are given 13 sum of -3 raised to exponent k. All right, so for the first question, write down the values of the first three terms of the series. So the 2 is gonna be the first substitution. So we're gonna substitute u2 lapha ku-k. So it's gonna be a -3 raised to exponent 2. Sithola u9. For the second term, so substitute u3. So it means that the k value increase by 1. So ngoba siqala ku2 siya ku3 siya ku4 siya ku5 njalo. So it goes up in increments of 1. Okay, so next up, so substitute with 3. We're gonna substitute with 3. So we go about plus -27 plus, we go ahead and substitute with 4. So it's gonna be a plus 81. So the 9, the -27, and the 81 are the first three terms. These are the first three terms. In question. Then so you have 2.1.2. Write down the value of the constant ratio. So it means that the pattern that we have, or the series that we have, it's a geometric one. So to calculate a common ratio, which is r, so t2 over t1. This is term 1, this is term 2, this is term number 3. Or my calculator is t3 over t2. You know what, let's calculate both. Not that you have to, but just for the sake of this recording, let's do both. So one would be vele the common ratio yaphuma. So it's gonna be a -27 over 9, that's -3, or, and then t3 81 over -27. 81 over -27, I am actually getting a -3 as well. So yes, the common ratio is -3. 2.1.3, there's a question. They are asking us, will this equal to 2 minus 3k actually converge? Will it converge? Will it converge? Now, back, this is the same as above. Just got the, instead of ending go 13 term, it ends or it continues to infinity. The question is, will it converge? Explain your answer. All right. So we so will it converge? Will it converge? In order for an arithmetic sequence, in order for a geometric sequence that stretches to infinity to converge, the common ratio must be between a -1 and a +1, meaning that a common ratio yakho, it shouldn't be any less than -1 or bigger than +1. Komele idlalele between -1 no +1. Now, let's look at the common ratio for this particular series. Since R, the common ratio, is equal to -3, it will not converge. It will not converge. It will not converge. Why? Because R, the common ratio, does not, maybe you can say, satisfy the condition, the above condition. It does not satisfy the above condition. They're not expecting a calculation, rather, but they want an explanation. Okay, so just explain it the best way you know how. All right, so this is somewhat like almost a common question kuma question papers. All right, so we are still at the same question, same sequence as above, but this time around sino x la, sino x. All right, let me just erase this. Then siyaku 2.1.4. They're still asking us about that pattern, but instead of giving us the exact same thing, babe x la bigcine. So that's 13. That's 13. K is equal to 2 minus 3 raised to exponent k. Then go on to x la. Give your answer. Okay, they want us to calculate this, or in other words, evaluate or find the sum of the sigma and give your answer in terms of x. All right, so lana again, we need to expand this thing actually for the first three terms. Again, sifaka 2 la, sithola 9x plus, again siyaqhubeka sifaka, but do I have to get the second term? I don't think so, but let's get it anyway. Then you have about -27x, then go about 81x. Okay, go about 81x. I don't actually need the first three terms. I just need to a, because when we calculate the sum, CTA r raised to exponent n minus 1 divided by r minus 1. All right, so getting our a no n. Okay, so a in this case is gonna be 9x, and then r change, it's still -3 as before, and sitting our n as well. N is equal to, so when it comes to sigma notation, you always take the top part. You take the top or minus with the bottom, uti +1. So what is the top value? It's 13 minus what is the bottom, 2 plus 1. That's a form. That's what the formula states. 13 minus 2 plus 1. So it means that's in a 12 terms, or n is equal to 12. A, that's gonna be 9x. R, it's negative 3 exponent n, that's 12 minus 1 divided by negative 3 minus 1. Then we calculate well, minus 3 exponent 12 minus 1 negative 3 minus 1. Then 7 on 9x minus 13 to 860 equal to, so this negative 13860 calculator, or ngithole by calculating this, and then we multiply by 9, sithola negative 1,195,740x. So this is the sum, but as you share in terms of x, so I'm gonna leave it here. Then say hide Alena, perhaps let me bring it back, erase, and do the last question, 2.2, question 2. So this is 2.2. Now we are given a quadratic sequence. A quadratic sequence with a general term Tn has the following properties. We have T29 is equal to 1166. I think this is gonna end up on a, it's gonna end up as a, what in this thing, come on, I think it's simultaneous. I don't know, but let's check. Then Tn minus 1 is equal to 3n minus 4. All right, Tn, so this actually tells us, this is actually indicating, come on, Ben, it's indicating the first difference. This is telling us this property, the second property is telling us we are actually, or how to find the first difference for this quadratic pattern. So you told her like this: determine the value of the first term of the quadratic sequence. All right, of the quadratic sequence. All right, so for this one, determine the value of the first term of the quadratic sequence. Okay, so in a T29, you know what? Let's do this. Try to sort of like reconstruct the number pattern. It's not T1, T2, T3, maybe it's not T4. Alright, so as told T2 no, the difference between T2 no T1, so you figure out 2 in the second property, né? So the T2 minus T1 over 2 minus 1, that's 1, is equal to 3, where there's n, you figure out 2 again, minus 4. Let's check it. 3 times 2 minus 4, out 2. I'm getting a 2, so it means that the difference between T2 and T1, that's 2, and then T3 and T2, going back to the second property, you figure out 3 minus T, 3 minus 1, that's 2, right? And then go about 3 minus 4, that's 9 minus 4 is equal to 5. And then send to T4, but how am I going to implement 29, the T29? You know what, let's just continue. therefore siyoba t4 minus t5. Remember, we are using the second property. So in the place of n ngifaka ubani u4. Actually it's not 5, it's 3 la. It's gonna be 3, t3. Ngoba in the place of n ngifaka u4. You find out the difference between 4 and 3, and then 4 minus 1, that's gonna be 3, equal to 3, 4 minus 4 is equal to 12 minus 4 minus 4, 8. So that's gonna be 8, and then let's get the second common difference. I think the second common difference is gonna be key in cracking this whole thing. So 5 minus 2, that's 3, another 3, another 3. Therefore we know that whenever we calculate the n term of a quadratic pattern, the second common difference is always equated to 2a. The second common, the first common difference is going to be equated to 3a plus b, and then the t1, which is the first term, it's going to be equated to a plus b plus c, right? Now as calculator a, so a to a is going to be equal to 3, then a is going to be equal to 3 over 2, so divide up both sides by 2, so no a. Then let's go to this equation, this one, 3a plus b is equal to 2. In the place of a ngifaka 3 over 2 plus b is equal to 2. Then go about 9 over 2 plus b is equal to 2. B is equal to 2 minus 9 over 2. Then b is equal to, let's check, 2 minus 9 over 2, and to allow negative 5 over 2. Negative 5 over 2. So this is b. This is b. Ngishota ngo c. So my aim kahle kahle is actually to go about it by finding the actual n term. Total a, b, and c, substitute it and get n term for the sequence. Then in the place of n, substitute a 1 and get the first term. Alright? So that's my plan. That's my plan. But now, how do I calculate c? How am I going to calculate c? Oh, okay. Alright. Okay. Tn is equal to an squared plus bn plus c. I have an idea. A naye, b naye, however c naye, but I'm calculator using that T29. So sometimes, you just need to start doing something before the whole thing can click. Né? Now notice something, or just take note of something. Whenever they give you something, even in physical sciences, whenever they provide you with information, like at first it felt like T29 anyengikhona ukumsebenzisa in my calculation, right? Maths abakuphi information mahhala. Whatever information abakupha yona yonke uzoyisebenzisa in that particular calculation, right? If we a calculation without using some of the provided information, just know that something is not right. Something is not right. Okay? So the 29, even in physics, if they give you velocity, acceleration, I don't know, displacement, then when you end up using velocity in the acceleration, displacement, after doing our calculations work, just know that there's something you did wrong, right? So we come to this formula, we substitute what we calculated so far. In the place of a, ngifaka 3 over 2 and squared plus, in the place of b, ngifaka negative 5 over 2, so it should be negative 5 over 2 n plus c. Nazo ke the 29 I'm gonna substitute into this equation. So I do have a t29. T29 is equal to 3 over 2. Where does u n ngifaka u29 minus 5 over 2, 29 plus c. T29 siyazi ukuthi ubani u 1166 equal to, then I think we can just calculate 3 over 2, 29 squared minus 5 over 2 go 29, then sigano 1189 plus c. Transpose 1166 minus 1189 is equal to c. 1189, then minus 23. Now saying no a, no b, no c, then I can just erase erase this part, then ngithi-ke na i-formula yami naseyiphelele ke, this is the n term, 3 over 2 n squared plus, not plus, minus 50 minus 5 over 2n, then go by minus 23. Therefore ngivele ngithi t ngifuna, since ngifuna u-term 1 la kuno n ngifaka u-1, 3 over 2 1 squared minus 5 over 2 1 minus 23. 3 2 1 1 squared minus 5 over 2, then go minus 23. Yes, 2 to minus 24. So the answer is minus 24. Here's the final answer, minus 24. This brings us to the end of question number 2. Now let's jump to the next question of this question paper. Alright, now with the question 3, it's all about our functions. Now the question 3, it's a two-part question. As you know, 3.1 is involving a hyperbola, and then we have the second part of the question, which is a parabolic function. So lana we are interpreting 3.2 the parabolic function. Ngapha we're gonna sketch 3.1.3. it's gonna be sketching. All right, so you know f of x, that is 2x plus 3 over minus x minus 3. 3.1.1, but it showed that f of x can also be written as, so the hyperbolic function is in this form, not in that form. Okay, so we need to rewrite that or recalculate or simplify for a better word, or a better word to this. We need to simplify this to that, the standard form of a hyperbolic function. Okay, so for 3.1.1, so you know f of x, the question lebaro 2 marks, I think maybe 3 marks was gonna be worth what we are gonna do for the simplification. Okay, so number 1, I think an important thing to note, the f of x we want to simplify to as a denominator that is x plus 3, meaning that this part of the fraction, first into we need to apply a sign change rule or take out u minus 1 as a common factor, because the x must be positive, the 3 must be positive as well, right? So we're gonna simplify this, but first we need to get rid of that negative denominator, divided by minus x plus 3. I took out to negative 1 as a common factor. because at the end of the day, the calculation letter green, it must have an x plus 3. Must have an x plus 3. So again, we need to take this minus, right? Take it to the numerator again, asifuni that negative on the denominator. So about minus, or instead of me saying asimbeke lapha phezulu, let's just place it on the side for now. 2x plus 3 over x plus 3. Alright, x plus 3. Next step. The next step is to break this 3. Or maybe not break, but rewrite the 3 as a difference of two numbers. It will make sense just now. Ngifuna break that 3 such that divided by x plus 3. I want to break this 3 such that when one of the numbers combine on 2x, it can be factored, meaning that 3 I can rewrite as plus 6 minus 3. A plus 6 subtracting 3, it takes us back to with 3. It can be even maybe a case of 7 minus 4. Even 7 minus 4 usinikeza u3. Even 8 minus 5 nayo usinikeza u3. But I'm choosing u6 no 3 because uma ngithatha u6 ngimcombine nalo 2, I can factorize that. That is the whole idea. That is the whole idea. Ngobhala lo 3 as u6 minus 3 instead of 8 minus 5 or even 7 minus 4. I need to 6 minus 3 because uma combine lo 6 now lo 6 now lo 2x, I can get my factors, right? Now I'm gonna group 1 and 2 as one thing. Keep a common factor. There's a common factor of 2. I'm gonna take it out, and then lo 3 ahambe I1. Of course, this is our target. This is our target. The denominator is fine. 9. It's x plus 3. Now, how do we deal with this negative again? For now, let's just focus on getting the common factor out, which is 2. So it's minus 2x plus 3 minus 3 divided by x plus 3. Now we're gonna apply this rule. If I have on the numerator a sum or even a difference of two terms on the numerator divided by a single denominator or a binomial or whatever, let's place C la, I can actually say a over c plus b over c. So tata the denominator or divider each and every term on the numerator to that, right? So this is the same principle as we apply la. So we apply la. Keep in mind, this is our goal. This is our goal. F of x is equal to minus, then mhlambe ngakufaka ku bracket lo ngithi 2x plus 3 over x plus 3 minus 3 over x plus 3, right? Uyabona lo x plus 3 sekaphumile ufana nalo, then leyo cancela lengisale nobani no 2 lapha, right? No 2 lapha. So I'm gonna close this bracket, then le cancela lena. I'm now left with u minus in bracket about 2 minus 3 over x plus 3. F of x is equal to multiply by the negative inside the bracket, so 12 plus 3 over x plus 3 no minus 2, which is now exactly the same as that. So you understand with the y no, the 2 marks is actually not enough for this calculation, man. No, so this is how you show that can be written to that. This can be written to that. Now 3.1.2, they want us to calculate the coordinates of the intercepts with the axes. So sorting about the x-intercept and the y-intercept. So let's calculate the y-intercept first. Y-intercept. So we're gonna let x to be 0. So to y is equal to 3 over x plus 3 minus 2. Then c to y is equal to 3 over what is x? What is x? What is x? X is 0 plus 3 minus 2. Y is equal to 1 minus 2 is equal to minus 1. So your y-intercept, it's gonna be 0 and minus 1. X-intercept again. X-intercept. We let y to be 0, then y 0, 3 over x plus 3 minus 2. Transpose 2 over positive. 3 over x plus 3. Divided by 1, cross multiplier over 2. X plus 3 equal to 1 times 3, that's 3. Then go about 2x, go about 6 equal to 3. About 2x equal to 3 minus 6. Okay, this is basic algebra. Minus 3, then divide on 2 both sides, go about minus 3 over 2. Then minus 3 over 2 and 0. And 0. Okay. Mhlambe nangawabhala la. So now my x-intercept wethu la. My intercept wethu 0 and negative 1. No, negative 3 over 2 and 0. Ta-da. Okay. Alright, we erase this part, then your sketch again. We are now going to sketch. We are going to sketch like this. And like this. And like this. Then your y-intercept. I mean y-axis and the x-axis. Alright. Therefore, siya sketch again. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Alright, so as plotted y-intercept, it's 0 and minus 1. 9. 0 and minus 1. Then it's minus 3 over 2 and 0, which is negative 1.5. Naila. Negative 1.5. This is negative 3 over 2 and 0. Okay. Then we also need our asymptotes. Now asymptote yokuqala minus 2, y equal to minus 2. It's the first asymptote. Minus 2. Y equal to minus 2. Then sibanenye asymptote x equal to minus 3. So it's this equal to 0, x the subject of the formula. 1, 2, 3. X equal to negative 3. Alright, therefore we need to sketch this. A positive, by the way, the a value is positive, so I'm expecting the function yami ihambe so and so, with respect to our asymptotes, of course. What's happening? Alright, so connecting so it So this is my function. Okay, this is my function. Then 3.1.5, 3.1.4, I mean 3.1.4. Determine the equation of the axis of symmetry of, or the axis of symmetry of f, which is a decreasing function, meaning that since it's a decreasing function, okay, this is a typical hyperbola in a two yama axis of symmetries, this one and this one. The first one has an increasing gradient, right? Or ungathi it's an increasing function, right? Why? It's because of the gradient, it's positive. This one is a decreasing function because the gradient is negative, right? So Tina, we are looking for this one, and we know that the one with the decreasing function is always calculated using this formula, minus x plus c. Tina, our task or job is finding i-value ka-c, right? Okay, so udinga ama asymptotes wakho, the point of intersection yama asymptotes wakho. So we know ukuthi the first asymptote is equal to minus 2, sithola la. The other asymptote is equal to negative 3. It's coming from the denominator. We substitute to x as minus 3. We substitute to y as negative 2. Then we solve for c. Negative 2 root 3 plus c transposer minus minus, then c is equal to minus 5. Therefore, that equation for the axis of symmetry goes about minus x minus 5. This is what we have. This is what we have. Then siyalapha ku 3.1.5. Determine the values of x for which f is decreasing. Okay, all right. Now you need to understand something with a hyperbolic function. Your hyperbolic function, it's either ya increase or ya decrease, right? Like this one in it, we say this one is decreasing. If I read the graph from the left going to the right, the graph is decreasing. Even the other part of the graph now, it's decreasing as well, right? So I can safely say this function, did I erase? Yeah, now this function is actually decreasing by nature. So I can just give them a domain. I can just give them the domain. So the x element of real numbers where x is not equal to negative 3. So if function here decrease across the entire domain except for where x is equal to minus 3, because that is where we get the asymptote yet. Where f of x is bigger than 0, meaning that where f is above 0, where f is above, where the function is above the x-axis. Let me say that. Going back to this function, right? Ngizokukhomba la igraph yami where f of x is up, where f of x is greater than 0. Where f of x is greater than 0, it's this part. It's this part. This is negative 3 over 2 and 0. And then you asymptote it. That green part of the graph, this is actually where f of x is bigger than 0, where the graph is above the x-axis. Now, had they asked us to find where f of x is less than or equal to 0, it's the purple part of the graph. No, let me use blue. This part is below the x-axis. This part is also below the x-axis. So now the answer yethu la, it should be okay, this is A, there are no B now. It should be between minus 3 less than x less than or equal to negative 3 over 2. Going back to the function, you can see with the green particle la, and then it approaches infinity but never touches. We don't include the infinity. I mean, we don't include the asymptote, because the asymptote is where the graph is undefined corner, so we cannot include that one, right? So hence solution yami give us this. Okay, so this is 3.1 of question 3. I can erase Lana and go to the last question, the last part of question 3. Sketch below is a parabola f and a straight line. So it's not two functions, it's a straight line and a parabola. Who R and S are the x-intercepts. Now voila. And P is a turning point. Now P da. G has a x-intercept at R. Calculator coordinates ka R, which is the x-intercept for both UG no F. So 3.2.1, we have no other option except for using the straight line to get coordinates ka R. So since R is the x-inter, we're gonna let y to be 0. So going back Lana, we're just gonna say 0 is equal to 3x plus 6. Transpose go minus 3x equal to 6 divided by minus 3 x will be equal to negative 2. So therefore my coordinates are minus 2 and 0. Determine the equation of the parabola. Wow. That's a question paper ngithatha kancane. Yeah, he loaded this question. Okay, so first of all, in order to get the equation for the parabola, we're gonna need our x-intercept to get the equation. I do have the x-intercept yami yokuqala 9, negative 2 and 0. S, I need to calculate this one, right? I can calculate because already I have a turning point already. I already have a turning point, so I can calculate my coordinates ka S. After finding my coordinates ka S, I'm gonna use this equation to calculate the x-intercept. To calculate the actual equation. I'm gonna have the x-intercepts substituted in here, then in calculative value ka A, then FOIL out and get the equation here, right? Alright, so look, did you know what the x coordinate for the turning point can also be calculated as x-intercept number 1 plus x-intercept number 2 divided by 2. So I'm going to use this formula to calculate the x-intercept S. So the x-intercept for the turning point, that's a negative half. We substitute x1, it's minus 2, plus x2, it's the x-intercept for S, cross multiply about minus 2 times 2 is negative 4 plus 2x2, then transpose up about positive 2 equal to, then about 2x2 divided by 2, then x2 becomes 1. x2 now becomes 1. So I'm my x-intercept again, right? X-intercept. Now y is equal to a x1, it's plus 2, and then x2 let's try to calculate 1, So substituting into this equation, you have our minus 1. Lights plus 2 because there's a negative, and a negative times a negative lapha, it gives us a positive 2. Okay, so to calculate to A, I'm gonna take the turning point, we substitute and calculate to A. In the place of y, ufaka 9 A, and then in the place of x, minus half plus 2 minus half minus 1. Then 9 is equal to A, CT minus 1 over 2 plus 2 minus 1 over 2 minus 1. Then go out negative 9 over 4. Negative 9 over 4. Then divide them with negative 9 over 4. Negative 9 over 4 is your cancel. Then go about 9. Negative 9 over 4. And total negative 4. Negative 4 equal to A. Alright. Therefore, so y equal to, going back to this step, in the place of A you have minus 4. Then go about x plus 2 x minus 1. Alright. Then your foil, you're gonna simplify these two brackets. Now to simplify, you'll end up with minus 4 x squared minus 4x, then go about plus 8. So this is your final equation. But I also believe that even the turning point form on I7s, you can also use the turning point form in this case. Alright, so this is where question 3 concludes. Let's jump to question. Alright, let's get to question 4, the inverse plus an exponential graph. Remember, it's a two-part question. It's 4.1 as well as 4.2. So starting with the 4.1, the graph of f minus 1 equal to, the graph of f minus 1x is equal to the square root of 3x, where x is greater or equal to 0 is drawn in the sketch below. And then the f minus 1 passes through the point A, nangu A, right here. It's this point here with 3 and 3. 4.1.1, determine the equation of f in the form. Right. For the first question, we have f minus 1 x equal to the square root of 3x. Okay, this question paper as a whole, man, it's low-key a bit tricky, so, but yeah, not difficult, but just low-key tricky, so, but lana ke basipe an inverse. So basically whatever function abasipe yona la, the f minus 1, it's an inverse function. It's already an inverse function, so we need to revert it back to the original function of 4.1.1. so it's just basically saying y equal to the square root of 3x, right? This, we need to remove this and change it to y first. Then from lanage we swap ama coordinate, ama variables with, so it's gonna be x equal to 3y like this. You now have the f function. So initially we had the inverse function, so we are reverting it back to the original function. This is what we have. But now the question 80, make y the subject. So we square both sides. In this case we're gonna say square, we remove the square root so that we can solve for y. Then c1 of 3y, then we divide both sides by 3. We end up with the case of x squared over 3. Y is equal to x squared over 3. So we now have the function abayifunayo, which is f of x equal to x squared over 3. This was the original function. Alright, so for the next question, they are asking us for which values of x will f of x be less than f minus 1 of x, the inverse. The inverse. Alright, let's see. Let us see. Okay, check ala. Yeah, let me get this one. I black it right. Black is perfect. Okay, so I'm gonna try to plot. I'm just gonna do a rough sketch. I'm gonna try to plot f of x. If I plot f of x, the function is gonna look something like this. It's gonna look something like this. This is f, the original function. The one I plotted is the inverse of f. Okay. Now the question is, for which values of x will f of x be less than or equal to the inverse function? In other words, in which part of the graph is f underneath the inverse function? It's this part here. This is f, the green graph. Then we have this red one, the inverse function. So I'm going to show you where the graph, okay, let's say B already corner, it's that point of intersection. It's B. Okay, it's B. So for which values of x is f ngaphansi we inverse graph? It's between A no B. You can clearly see that f now is underneath the inverse function, which is the red one. Okay, so which values do we find the part of the graph where f ngaphansi, then the inverse is above? It's between B and A, so it means that it's between 0 and 3. For which x values? So 4.1.2, it's between 0 and 3. Between 0 and 3. We write it like this. Noma mhlambe ungayibhala like this with the x element of 0 included, 3 included. Ungayibhala nakani, is still fine. Okay, so this concludes the first part of the question. Alright, so just going back la, personally I would say sketching the original function was actually necessary so that uzoyibona at this problem. Okay, so if you come across a problem or a question like this, just prepare a rough sketch to help you answer the question. Okay, to help you answer the question. Alright, now 4.2, we are given g of x. Determine the equation of g minus 1 in the form of y equal to Alright, so we want the inverse function in this case. So we have g of x, that is 1 over 3 x. Okay, again we remove g of x with y. Okay, with y. Then in order to get to g minus 1, what do? We swap the variables. We're gonna have x here, a third raised to exponent y. Therefore, then we do what? We apply the log definition. So we make y the subject, then we're gonna have a log 1/3 of x. We are applying the log definition in this case. The y becomes the subject, the x becomes the number, and then 1/3 becomes the base of the log. So this is y equal to log of 1/3x. That's the inverse of g. Then go 4.2.2. We'll have to sketch the inverse graph again now. We're gonna have to sketch the inverse graph. Let's go ahead and do that. So let's prepare grid like this. Like this. You know what I'm thinking? I'm thinking let's do this for this problem. We can perhaps sort of like do a table method for sketching and city maybe y, x, y, x, then y, right? Then mhlambe we start here, city 0, 1, 2, 3, maybe let's add an extra point plus city 4. The x values I choose, I'm just gonna calculate my y coordinates again now. So this is y, and then this is x. All right, calculator, log 1/3 and 0, it error. So I'm gonna put up an infinity sign. This is error. So the log of 1/3, 0, it's error. There's no value for that. Then for 1, I'm getting 0, and then for 2, I'm getting minus 0.63, and then for 3, I'm getting a minus 1. Let's check out 4. I'm getting a minus 1.26. All right. So we have 0. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. All right. So we sketch, but it's okay. You'll see. First, second, third, fourth quadrant. The graph here too will only exist in the first quad and the fourth quadrant. The first and the fourth quadrant, right? The second and the third, the graph won't be part of that. How do I know? Because of this. Y, where x is 0, we have an error. We get an error. So it means that the y axis is actually the asymptote for this graph. So it means that the graph here to izohamba like this. Yeah, like that. But now we'll have to sketch again. So the y is error, so it means that we have an asymptote along the y-axis. So y, when x is 1, we get a 0. It's point number 1. When x is 2, we get a minus 0.63 somewhere here, just before 1. And then whenever sithola 3, sibona minus 1 is somewhere la, and then 4, that's minus 1.26 somewhere la. So the graph is gonna look something like this. Okay, not the best in the world, but it sends a message as well. Okay, so sketch a graph of g of -1 indicating any intercepts with the axis as well as one more point on the graph. Okay, so sinalo 1 and 0, that's the intercept, and you can just choose any point. I think I prefer this one because I'm a whole numbers. We're gonna have 3 and -1 for this point right here. We now have a sketch for the inverse graph. Now asijampele ku 4.2.3. 4.2.3. 4.2.3. The graph of h, let me write it down. A third raised to exponent x plus 7 passes through the point -2 and 10. Calculate the value of a. Okay, it's just a matter of substituting and working out the value for a. So we're gonna do that. So x -2, then y is 10. So for the h of x, which also represents y, I'm substituting with 10. A 1/3, then where's this x? I'm gonna substitute to -2 plus 7. Transpose to 7, we're gonna have 3. A third minus 2. Alright, so you can either do it this way, 1/3 minus 2, then they are cancelled, then you punch this whole thing on the calculator. But I'm not gonna do that. I'm gonna do this. A, then go about 3 minus 1, then minus 2. We simplify or remove that bracket. The -1 multiplies that -2 is equal to 3 squared a, which is 9. A then is divided both sides by 9. I get 1/3 as being equal to a, right? Because over 9 cancel 3/9, it's 1/3. So a is 1/3. That's the value for a. Okay, for the last question. All right, so they want us to compare OH no G. So they are saying to us a transformation took place. A transformation took place from H to G. Describe the transformation. That's the question. All right. Okay. For 4.2.4, let's write down the full equation. That's gonna be h of x. We just calculated a. We got to 1/3 x plus 7. That's h. The h was transformed or translated to g. G is this function, 1/3 x. Okay, x. If uthatha ukubheka la from h to g, kusuke u7 kwasuka nalo 1/3, okay, kwasuka nalo 1/3. I think what we should do first is to deal with the h function. There's something must be done. Something must be done. The bases are the same. We can just multiply out and add the exponents, because I don't know how am I going to get rid of this 1/3. I know go to 7. I know how I'm going to deal with the 7. That's out of the way. But what about the 1/3? That is why let's simplify first, then we can have a discussion afterwards. So the h of x we can resolve or simplify further to this 1 over 3 x plus 1 plus 7. Multiplying powers of the same base, you add the exponent. So the 1 over 3, the first 1 over 3 is raised to exponent 1. The other 1 over 3 is raised to exponent x. Bases are the same, we add the exponent. So the x plus 1 is x plus 1 plus that 7. Here's g. 1 over 3 x. Okay, now let's have that discussion again. How do we move or translate to h to g? The 7 must fall off and that 1 must fall off. Instead of saying the 1 over 3 must fall off, I'm saying now 1 must fall off. Okay, must fall off. Back. Look. In order to move from h to g, perhaps let's imagine the situation of translating our function from g to h. I would have to add 7, meaning I'll have to move the graph upwards by 7 units. And then for that 1, we can justify it by saying I would have to add 1, meaning it's same as saying I'm moving the graph 1 unit to the left. Okay, 1 unit to the left. If I'm moving from g to h, but now I have to reverse the whole process again, I would do what? I would move 7 units down. I'm doing the opposite again now, right? I'm doing the opposite. So in order to get rid of the 7, it's like subtracting by 7. So hence I'm saying 7 units down. How do I get rid of this plus 1? By subtracting by 1. So that's like 1 unit, moving the graph 1 unit to the right, because when we add, we move to the left. When we subtract, we move to the right. Okay, so in order to move from h to g, I would have to move the function 7 units down and 1 unit right. So yeah, that's the end of our discussion for question 4. Now let's jump to question. This is the last question, or question 5 for this question paper. All right, so it's just a generic trigonometry question, if I may. When a simplification, right? We are simplifying here, right? Then, in a diagram, we're going to be using a diagram to simplify and an identity. Usually, maybe in a final exam or a June examination, you might even find maybe a, what is it called? A general solution question. Sometimes you even get maybe a proving question. Okay, so it's just a simple question. I hope you find it simple the way you begging a call. So 5.1, 5.2, 5.3 is just a 3-part question. 5 and the last question is question paper. Okay, so let's jump to 5.1, where we are provided with a equation and the angle is an element of 90 degrees to 270 degrees. So we're going to be using this information to identify the triangle yethu, so we draw in which quadrant. Determine without the use of a calculator and with the aid of a diagram the values of. So that diagram we're going to use it to answer these questions. So for 5.1.1, we are told they want us to find cos beta. However, we are provided with 5 sine beta minus 4 equal to 0. Alright, so first of all, we make the trigonometric ratio the subject of the formula. So we're going to have 5 sine b equal to 4 divided by 5 both sides. We end up with 4 over 5. All right, so we need to identify which quadrant. We need to identify the quadrant where we're going to draw a triangle yet. All right, I think an important thing to note, Laukuti, the sign is positive. So there's only two quadrants in which sign are positive. It's the first quadrant and the second quadrant. And yet we know that sine it's y over r. So x is missing. So we also need to calculate to x as well. Okay. Therefore, we come lana, and then we do this. All right. Now looking at the angle beta, but it's between 90 degrees and 270. So 0 degrees, we have 0 degrees, we have 90 degrees, we have 180 degrees, then we have 270 degrees. I did mention with the sense of sign positive, it means that it's either a second or first quadrant. However, another extra bit of information, but beta, the angle B, is between 90 and 270. So the angle is between 90 and 270. So in the third quadrant, we cannot draw a triangle yet. Why? Sine is going to be negative. So the triangle should be drawn gupi go second quadrant like this. Second quadrant like this. Therefore, we have angle beta like this, 90 degrees, and we have r that is equal to 4. We also have, no, that's y. R is 5. R, that's 5, and then y is equal to 4. And then let's calculate to x. X is going to be equal to the square root of r squared minus y squared. We just use Pythagoras theorem. Okay. Then the square root of, what is the value for r? That's 5. So it's 5 squared minus, what is y? Y is 4. That's going to be 4 squared equal to, say 5 squared minus 4 squared. I'm getting 3. But the 3 should be a plus or a minus, because whenever we take the square root of a number, the answer will come out as a positive or as a negative. So since the arm or the triangle is in the third quadrant, it means that x2 must be negative 3. That's important. That's very important. So we have x as minus 3, and we have y as positive 4, and then the r, or the radius, is equal to 5. Now we can answer this question here. Cos b. Cos b, it's x over r. Looking at the triangle here, so x is negative 3. X over r, that's going to be a minus 3 over 5. 5.1.2. I no longer have to sketch the thing is sketching up a puzzle, so we're just going to keep on using the same sketch. Cos 2b. Now, don't be tempted with the treated the above as the current question. They are not the same. This is 2b, this is b. We have an angle of beta on the sketch. We have an angle beta on the square on the sketch, not to 2b. So we need to solve this, which by the way is a double angle. So we can either use this one. We have 3 identities. You can use either identity out of the 3. So I'm just going to use this one. B is equal to 1 minus 2. Then we're going to substitute sine b, which is 4 over 5. And it's squared, so we're going to square this. 1 minus 2, 4 over 5, that's 16 over 25. equal to 1 minus 2 times 16. You know what, I'm just gonna punch the whole thing. 16 over 25, close bracket, then I'm getting O minus 7 over 25, 7 over 25, or let's try using a second identity, this one. I just want to check that I'm gonna get the same answer now. 2, and then cos B is this. It's negative 3 over 5 squared minus 1 equal to 2 minus 3 over 5. I'm punching the whole thing, minus 1. I'm getting the same answer, 7 over 25. Here we go. So out of the 3 identities, it's up to you to answer which one. Okay. Yeah. I did say on the previous question, this question paper is low key difficult. I jumpy easy, I jumpy easy. Quiet, ishayela phansi. But if you know your stuff, you can. This question is gonna be a breeze. This question paper is gonna be a breeze. All right, so 3B. On the sketch, I don't have 3B. I only have beta, right? So I need to simplify usine 3B. I need to simplify this thing. So what's the best way of simplifying this thing? Is using a compound angle. I'll do this. Sine 2B plus B. I can use this. Why 2B plus B? Why not maybe, I don't know, maybe 5B minus 2B? Alright, this is also equal to 3B. 2B plus B is also equal to 3B. If I use something like this, I'm creating a problem, or 5B. I'm using this because ngingak simplifier and end up with a 2B. I can solve a 2B further than a 5B. Alright, so using a compound angle, sine A plus B, we're gonna expand this thing. We're gonna expand it. So in expanded form, you have sine 2B multiplied by cos B. Is it minus? No, it's plus. Plus cos 2B multiplied by sine B equal to, okay, so sine double angle, we expand la. We're gonna have 2 sine B multiplied by cos B multiplied by cos B. Alright, double angle ga sine plus this. I don't have to expand. Let me show you why. Let me tell you why. It's because of a value cos 2B we do have. We can just substitute in here. Don't expand. This will create a bit of a problem. So let's just leave it like this. Expanding it will generate more work for us. So let's just leave it like this. Then 2, see, as I guess it is sine B. Sine B I do have 4 over 5. 4 over 5 multiplied by it's cos times cos, so it's gonna end up being a cos squared. So I'm just gonna substitute once and square. So cos B, what is cos B? Cos B, come on, it's minus 3 over 5 squared plus, then we must figure out cos 2B, which is substitute to minus 7 over 25. Then sine B, it's 4 over 5. 4 over 5. Then we punch everything. Okay. 2 4 over 5. Then minus 3 over 5. Square this. Plus minus 7 over 25 not squared. Wenzani manje? Wenzani? Ngibona uyaphapha. Punch into zakho la. Muno. Then our final answer is 44 over 125. This is the final answer for 5.1.3. 5.1.3. Alright. Okay. Let me hide this part. Then we go back, see 5.2. We are now simplifying it. We have an expression with a reduction formulas. I also see a co-function over there. Okay, I also see a co-function corner lab. Alright, so we have the expression as minus 180 minus theta times tan 180 minus theta multiplied by, or minus theta divided by cos squared 90 plus theta, yes, cos squared plus 3 sine squared theta. Okay, all right. We need to solve this thing first. There's several ways we answer. In fact, two ways. Inside this bracket, you actually have a negative angle. So the best way to get rid of the negative angle is to actually add with 360 degrees, right? So in a formula got sine 180 minus theta, not minus 180 minus theta. That's very important to note. Hence I'm saying we have a negative angle in that bracket, minus 180. In fact, I think what do you think? Let's do it. Okay, I'm gonna take it step by step. Plus 3, let's find something bright. Plus 360. I'm adding to 360 because we have a negative angle inside the bracket. Multiply. Okay, now we can solve. This one we can solve. Tan 180 minus theta. This is found in the second quad, and in the second quad tan ujano negative. So simplifying that, we're gonna end up with 2 minus tan theta multiplied by cos negative theta. Again, sin a negative angle, we put in a 360. We add 360 to that negative angle, which is this case again. Vala bracket la. Okay, then cos squared 90 degrees plus, for the fact to ratio yethu is squared, whatever answer esoyithola, it's always gonna be positive. So the cos squared 90 degrees plus, I know it was supposed to be negative, but because of the cos is squared, the answer is your pumi negative. Your pumi positive. So we're gonna have a positive sine squared theta plus 3 sine squared theta. Okay, therefore the 360 and that negative 180 added, they give us a positive 180, like that, multiplied by minus tan theta multiplied by, so the cos 360 minus theta, it's a positive cos theta. Okay, there's a better explanation that can be given, but I just want to take you step by step along the process so that you understand as to why ezinye izinto ziresolveka the way ziresolveka ngakhona, or zisolveka the way zisolveka ngakhona. We have that equal to, let's simplify this ratio, this formula now. It's gonna be a positive sine theta multiplied by, now cos is an identity, we change it, sibano minus sine theta over cos theta multiplied by cos theta divided by 4 sine squared theta equal to, so the cos will cancel out that cos, the sine multiplies that sine, that's minus sine squared theta divided by 4 sine squared theta. Here we go. This divide this, we end up with a minus 1 over 4. This is our final answer. This is our final answer. Okay. For the last question, the identity of 5.3. Honestly, I was gonna say, yeah, video yeti pelilala. I don't know how to approach this thing. I have no idea how to approach this thing. But I think, okay, it's obvious we have to take the left hand side. We have no choice but to take the left hand side. Okay, yeah, it's gonna be a mess. 5 marks, okay. Let's grab the left hand side. The left hand side is equal to 1 over 8, 1 minus cos 4x equal to 1 over 8. I was tempted to change this one to cos squared minus cos squared plus cos squared, but no, we don't change the 1 unless uduzane mhlambe no sine squared or cos squared. In this case, we have cos 4x. Now 4x is an even number, all right? It's an even number, so we can treat this as a double angle. We can treat it like this, as 1 minus cos 2 2x. It is a double angle because 2 times 2x is 4x, so double angle of 2x. So let's resolve this thing. Say maybe to something like this. I want to get rid of this one. On the right hand side there's nothing about 1, and I have to find a way to get rid of this 1 over 8. So in the meantime, let's try to get rid of this one. So I'm going to change this to one of the identities that can cancel out that one. So 1 minus, mhlawumbe singasebenzisa different color, city open bracket. So we want to cancel that one. Is that doable? Is that even a good idea? Is that even a good idea? You know what? I'm rolling with that idea. If it fails, it fails. 1 minus 2 sine squared 2x. It's not x but 2x. Let's close the bracket, follow the bracket, 1 over 8. Okay, it's gonna work out. Back sine squared 2x, then close, cancel, they cancel each other out, then we end up with 1 over 8, 2 sine squared 2x. Okay. All right. Let's go back. Hey, Ashaya, right? Ashaya, yep, like, yeah. 1 over 8 times 2, we end up with 1 over 4 now. Yeah, it's 1 over 4 sine squared 2x. All right. Sharp. Then we're gonna do some magic here, much. Now, sine squared 2x. This is not a double angle. It's not a double angle. A double angle here shouldn't be squared. However, there's a workaround. We're gonna take the squared, see bigger outside the bracket like this, so that inside the bracket I'm left with a sign that is not squared. Yes, the sign was squared, but the squared is removed and placed it outside the bracket. So we're gonna continue and say, let's expand like about 2 sine x multiplied by cos x close bracket squared. After simplifying that double angle, I square again. I bring back the squared. So I'm going to square each and everything inside the bracket. Okay, so that the square is going to square that 2. The square will square the 2 squared, that's 4. Sine x, that's sine squared x multiplied by cos squared x. I was taking the the squared back into the bracket. Now I can multiply by that 1 over 4 into the bracket again. So 1 over 4 times 4, that is 1. Then you allow sine squared x cos squared x. This is the same as the right hand side. You know, silly of me to say question 5 is the last question. There's question 6. Oh my goodness. Oh my goodness. Okay, that's trigonometry. Yeah, it trigonometry involve graphs as well. Okay, so let's jump to the next question. Question 6. I thought question 5, for some reason I thought question 5 was the last question in your question paper. So question 6 is the last question. I promise, guys, there's no question 7. Question 6 is the last question. All right, it's trigonometry again. As good question 5, we're discussing in trigonometry, but the simplification part, question 6, it's all about trigonometric functions or graphs. There's also a general solution problem, like with 6.1. If you are watching a snippet of the whole walkthrough of the question paper, just check the description box. There's gonna be links, not links, but a link to the whole question paper. Okay, because I'm planning to split the whole recording, the entire recording, into each question. So you might be probably watching question 6 right now. If you want to see the whole thing, just check out the description box. 6.1, determine the general solution of cos x minus 45 degrees. That is equal to sine 2x. Okay, sine 2x. So this is the entire equation. The entire equation, 2x. Okay, so when getting a general solution, you want to find yourself in a position where you only have one trigonometric ratio equal to some value. Then you can get the general solution in that case. Okay, in that case. But now, here's a situation. The situation is that we have two totally different trigonometric ratios. I have cos on the left and sine on the right hand side. Okay, and the angles are different. So this is a case where we have to use a co-function or a co-ratio, right? So I can do the following: cos x minus 45 degrees equal to, I can rewrite, in fact I have to rewrite to sine as cos using the co-function. So I'm changing sine to 90 degrees minus 2x. When you solve this, it's taking you back to sine. Now here's the reason why I have to use a co-ratio. The reason is that so that the cos and the cos can dissipate, or they can cancel each other out. so that ngisale nalama angles, the x minus 45 and the 90 minus 2x. If I can't resolve the equation to a trigonometric ratio, only one trigonometric ratio equal to some value, this is another thing you can do, making sure that the left hand side has the same trigonometric ratio as the right hand side, which we achieved. Cos, it means that the angles are the same. Okay, it means that the angles are the same. Now, the angle on the right hand side, it's gonna act as the reference angle. It now acts as a reference angle. Okay, then we check or identify the quadrants in which cos is positive. That is the first quad and the fourth quadrant. So in the first quadrant, this is gonna be our solution. X minus 45 degrees equal to 90 minus 2x. Ungakhohlwa phela, plus okay times 360 degrees, right? Okay, therefore from lana ke we're gonna transpose this over to the right hand side and then touch this thing to the left hand side. So x plus 2x equal to 90 plus 45 degrees plus k multiplied by 360. X plus 2x, that's 3x, equal to 90 plus 45, not minus, plus, that's 135. Can't why you so much, plus k times 360. Yeah, then we divide by 3, divide by 3, divide by 3. X now becomes, what is divide by 3? I think that's 45. Right, 45. Why Papa so good? Okay. Then 360 divide by 3, that's 1. Yeah, 120. I'm sure of it. This is the first solution. Now in the fourth quadrant, we're gonna have x minus 45 equal to, keep in mind, the 90 minus 2x, that's a reference angle. So in the fourth quadrant, we have the formula 360 minus that reference angle, 90 minus 2x minus 2x plus k times the 360. Then sibana x minus 45 degrees, 360 minus 90 plus 2x plus k times 360. Then x minus 45 equal to 180. It's gonna be 180 plus 2x plus k times 360 times 360. Okay, then from lana again we do what? We transpose 2x, nakafika ngalo minus 2x, we're gonna have a minus x, and then 180 plus 45 plus, interesting, okay, plus then plus 3k 360 minus x is equal to 45 225 Okay, something doesn't make sense. Okay, 270. Yeah, ngiyablanda ngilele. ngilele, ngilele, ngilele. I'm sleeping. Why am I sleeping? Yashaya le maths. Yashaya. Yashaya vele. Yatlabhana, yatrabhana le nto le. Yayazi. Yatrabha. Itrabha ukhohlwa igama lakho. Blind. Finish and clear. Yakushaya right. Okay, then we make x the subject of the formula. So we divide both sides by negative. So we're gonna have 3, negative 315 minus k times 360 degrees. This is the next general solution. Okay, so getting to the second part of the graph again. Second part of the question. 6.2, we are given a sketch of two functions, f no g. Okay, the f and g. Now, in the diagram, graphs of f and g are drawn for the interval minus 180 to a positive 180 degrees. That's the domain. A is a minimum point on G. Now A is the minimum point and C is a maximum point on both graphs. The two graphs intersect at B and C, then D. Okay, that's obvious. Okay, they're just telling us the obvious, whatever what is presented on the graph. Okay, now they want us to give the period of G. 6.2.1, the period of G. Okay, all right. G is equal to x minus 45 degrees. All right. A period is calculated as 360 for both cos and sine divided by b, which, by the way, the b is the coefficient of x, b is the coefficient of x. We take that coefficient, we divide it by 360. If it was a tan graph, we're gonna say 180 divided by b. Okay, divided by b. I'm plugging you. This is a formula that we use to calculate the period whenever we are given a equation. Now, let's say, just for argument's sake, let's say what if the equation wasn't given, but the graph was provided. Okay, a period, siyazi ngokuthi it's the period, it's the degrees it takes for the graph to complete one full wave. All right, so I think the best method to go about finding a period for this graph was actually using this formula, because just looking at this graph, you actually cannot tell where the graph starts and completes a wave, right? Iqala la G, it does this, it does this, it does this. You actually can calculate. Then you tata where the graph ends, we subtract the number of degrees where the graph starts. 180 minus negative 180, it's 360. So even if we do the calculation this way, b, by the way, it's 1, that's the coefficient of x, it's also 360. So using the graph, you're gonna do this, where the graph ends, which is 180, minus where the graph starts. Beg, mina, I'm saying from la to here, the graph completes one full wave. It's not so obvious. It's a discussion I don't want to get into right now. But I can see that just by observing, that is where the graph completes one full wave, minus 180. When you do this or find the value for this, you're gonna end up with 360, which is the same as above, which is the same as what we calculated above. Okay, so I'm just gonna take this down. The period for G, it's 360. 6.2.2. Lapha ku A, they want us to write down the coordinates of A. They want us to write down the coordinates of A. Yeah. Okay. Okay. All right. I think I have an explanation for A, but for B, I'll explain once I get to it. Okay, once I get to it. But let's start our conversation now. Y is equal to cos x. This is the parent function or the mother function. I'm saying mother function. Okay, so y equal to cos x. Cos x. This is the original function. Okay, so the function le, I know ukuthi iyoba ne minimum point. If I sketch the graph between la and la, I know for sure that I'll have a minimum point la at negative 90 and minus 1. If I draw this graph, I'm gonna have a minimum point. But now, since a graph here has been shifted to the right, né? To the right, to the right. It has been shifted to the right by 45 degrees. By 45 degrees. No. I'm lying. Let me fix this. It's negative 180. Negative 180 degrees. Okay, negative 180 degrees. But for the fact that the graph has been shifted to the right now 45 degrees, so it means that I'm now gonna have a minus 135 minus 1. So yosugagu 180. I'm gonna shift from 180. You move it to the right by 45 degrees. So lana, it's a negative 135 degrees, and then the maximum stays the same. So this is for G of x, which is the shifted graph, cos x minus 45 degrees. That is the minimum. Okay, that is the minimum. Now, I'll provide a better solution for A when discussing B. B, my coordinates B is actually the point of intersection between both graphs. Okay, I'm gonna make your life a bit easier, Nyana. So I will say this. You want the coordinates A, B, or ufuna coordinates C, or ufuna coordinates D. The best way to finding points of intersection for this particular problem is actually using your calculator. Punching this on the calculator, sketching this using your calculator, sketching this using your calculator. Actually, when you try plotting a sketch, when trying to plot a function on your calculator, question city mode. If you are using a Casio, you press mode, then uti to table, uti mode, then uti no what is happening? Isn't it table? Yeah. Okay. Uti shift mode, then we follow table. It's gonna depend on which type of Casio calculator, but just look for table. Press Okay. Yeah, wanna I'm losing it, man. I'm losing it. Sorry. You press mode, click number 3 a table ke manje. Yabona? A table. Kuyovela f of x, you generate the first equation. You plot the first function. Uma uqhubeka kuyovela g of x, you plot the next function as well. Then after the plot, you're gonna look for points of intersections on that table. Alright? On that table. So coordinates ka b uzowathola through calculator ke. Through a calculator. That's what I'm saying. I cannot actually project a calculator I am right now, but just try using a calculator. You'll actually get coordinates ka b. If you want a c or d as well, you can obtain them through that table. So b ngibona kuba 75 and negative 1 over 2 and negative 1 over 2. So these are the coordinates for b. 6 point, I think it be consistent, 6.2.3. Use the graphs to determine the values of x in the interval 0 to 360. 0 to 180. 0 to 180. For which f of x over g of x is less than 0. Is less than 0. Alright. Lana ke ufuneka ukuthi if f are negative, g must be positive, and vice versa. Meaning that if this is positive, this must be negative, or if this is positive, this must be negative. Let me show you. A function is positive if it's above the x-axis, is negative if it's below the x-axis. So one should be negative, then the other one should be positive. Okay, so uma uthatha ukubheka njenga la let me use green. Then I positive until la, and then I iba negative until kuphi somewhere la. Alright, so positive, negative at the same time. Alright, and guess what? That happens to be the only solution, because if we analyze this part of the graph, they are both positive. This part of the graph, they are both negative. So it's only positive and lana is negative. One should be negative, the other one should be positive. Alright, so it's between it's between 90 degrees and lana, since it's between 90 and 180, it's 135. So the solution is going to be between 90 and 135. We don't say equal to, because we want less than 0, not equal to 0, so we don't put an equal sign. So this is the solution for 6.2.3. Let's take this down and pull this thing up and reveal the final or the last question for question 6. Yeah, this is a monster of a question, a big monster, a monster of a question. Yeah, but uzayibona ilele man, sleeping. So for x in the interval x element of 0 to 180 degrees, so we're only paying attention, we are only looking for solutions between 0 and 180 degrees, a positive 180 degrees. If sine 2x is greater or equal to 1 over the square root of 2 cos x plus or sine x. Okay, plus or sine x. Lana bakubhayizisa la bakubhayizisa la ngasa bakubhayizisa la. This right hand side is actually the same as this. We just need to simplify or solve and show that. Bona sine 2x greater or equal to, let's remove the bracket, over 1 over the square root of 2 cos x plus 1 over the square root of 2 sine x. This is actually a value coming from special angles. So this can be shown or rewritten as sine 45 degrees. And then this one about cos 45 degrees sine x. Okay, why am I doing this? Ngifuna ukusimplifya loku to that, okay, to that. Alright, so that the formula is when's sense, so that it makes sense. I think let's put cos side. Go cos 45, then go sine 45 as well. Yeah, cos 45, cos x sine 45 sine x. Yeah, perfect. Alright, then sine 2x greater or equal to, why did I change the 2? Sine 45 is equal to 1 over square root 2, as well as sine 45 is 1 over square root 2. It will make sense for me to place cos la instead of sine, because I want a compound angle that reduces to x minus 45 degrees. 9, yeah. So in other words, it's like saying we are looking for x values where f of x is greater or equal to g of x. Ngifuna ukubona f angaphezulu, g angaphansi. F must be on top and then g abe ngaphansi. Okay, and babe equal as well. Alright, f phezulu, g ngaphansi. Now f phezulu, it's this part, g ngaphansi, now right here. Okay, so tricky. Now in order to answer this question, I actually need the x value or the x coordinate for the point intersection D. Consulting a calculator yakho again, I did say ukuthi getting your B, C and D, you actually need to use a calculator yakho. That's easy to do. Or you can use that general solution if you have the imagination to do so. But the calculator, I think, is the safest way of approaching it. The x coordinate for D, it's actually equal to 165 degrees from my calculator. Okay, from my calculator. If you do struggle with using a calculator for plotting trigonometric functions, just mention it. Leave a comment in the comment section. I'll generate or create a video explaining how to plot functions using a calculator. Okay, so the solution ila, it starts la, iphelelo lapha ku 180. Okay, but here's something that you can overlook: the equal sign la. So the point of intersection lapha ku point C we also need to include that. We need to include that. We're gonna include that the x coordinate for point C is actually 45 degrees. X equal to 45 degrees is the first solution, and where x is element of, we include the 165 degrees all the way up to 180 degrees. This is our solution for the last question and the final question for this question paper discussion. I hope we enjoy it. I hope we told some value out of this discussion. On a question, asikhulume in the comment section. You enjoy the video, ungakhohlwa ukulike, ukushare nabangani bakho as well. Thanks for watching. Asibonane on the next one.